According to property 6, sum of n odd natural numbers is given by n square, that is 1 plus 3 plus 5 plus 7 and so on plus n is equals to n square. Here is the table where you can see when we have taken one odd number, that is 1, its sum is represented by only 1, which is equals to 1 square. When you take two odd natural numbers, that is 1 and 3, so their sum is equals to 4, which is equals to 2 square. If we take three odd natural numbers, that are 1 plus 3 plus 5, their sum is 9, which is equals to 3 square. If we take four odd natural numbers, their sum can be written as 1 plus 3 plus 5 plus 7, which is equals to 16 and is equals to 4 square. When we have taken 5 odd natural numbers, their sum is 1 plus 3 plus 5 plus 7 plus 9. Sum is equals to 25 is equals to 5 square. So children, from this entire pattern you can see whatever is the number of odd numbers we are taking, the sum is given by the squares of the same numbers. Here comes the property 7. If n and n plus 1 are two consecutive natural numbers, then n plus 1 whole square minus n square is equals to 2n plus 1. For example, we can take 101 square minus 100 square is equals to 2 into 100 plus 1, that is 201. 555 square minus 554 square is equals to 2 into 554 plus 1, that is 1109. If you look at the pattern, you can easily see this condition is, the only condition is that the two natural numbers taken must be consecutive. This property doesn't exist for any two natural numbers. It exists only for two consecutive natural numbers. Now the most important property, that is Pythagorean triplet. The last property, for any natural number m greater than 1, m square minus 1, 2m and m square plus 1 represents Pythagorean triplet. This is taken from Pythagoras theorem itself, because whenever we obtain Pythagorean triplet, the three numbers in the triplet, they satisfy this Pythagoras theorem. For example, find the Pythagorean triplet whose one member is 8. Let 2m is equals to 8, so m is equals to 4. M square minus 1 is equals to 4 square minus 1, that is 15, and m square plus 1 is equals to 4 square plus 1, which is equals to 17. Therefore, Pythagorean triplet whose one member is given as 8 is 8, 15, 17. Now comes square root. Square root by prime factorization method. Now in the remaining part of the video, children, you are going to enjoy
how to calculate square root of a given number. There are two ways to calculate, or we can say there are two methods to calculate square root of a given number. The first one is prime factorization and the second one is long division. In this video, we are going to learn this prime factorization method, and long division method we will do in the next video. If you come for this prime factorization method, you can easily correlate it with the working that you have done for checking whether a number is a perfect square or not. So you won't find any difficulty. First of all, what is the symbol of square root? So children, here is the symbol of square root. The number which is written under this sign means you have to calculate its square root. Method will be told to you whether we require prime factorization method or we need you to solve by long division method. As we are going to solve by prime factorization method, so we will calculate the square root of 225 by prime factorization method. So as per name, you need to do this prime factorization again. So prime factorization of 225 by 3, it's 7, 5, again by 3, it's 25, by 5 it is 5, and again by 5 it is 1. So here is a prime factorization of 225. Children, first of all, without any root sign, we will express the number as the product of its prime factors. Now introduce this square root sign on both the sides. Introduced. Can you see that you are doing the same working as you did earlier? So no problem in doing this prime factorization. Square root by prime factorization is not a very difficult task for you. Now make pairs of like factors. Left side we keep as it is with root sign. Right side, from each pair we take out the, here we have made the pairs of like factors. From each pair we will take out one factor. So from the pair of 3 I have taken 1 factor, and from the pair of 5 I have taken 1 factor. And this leads to the cancellation of a square root sign. When from the pair of like factors you take out 1 factor, so what happens there? The square root sign automatically get disappeared. So as both the pairs are complete, so we could easily take out one factor. Now the product of factors is 15. So we can say square root of 225 is 15. Square root of 225 is 15. In the sequence, I would like to take the another number as 9604. Its a square root you have to calculate by prime factorization method. Same method, children, you follow the over here. We do the prime factorization of 9604. In the sequence, we take another number 9604. We have to calculate its square root by prime factorization method. Children, let's go for the prime factorization. You all have become very smart, so you don't need any assistance. You can go fast. Here is a prime factorization of 2, 4, 9604. Now let us express this number 9604 as the product of its prime factors. Now here comes the turn to introduce square root sign. On both the sides, let us introduce, this is square root sign, 2 into 2, and all the pairs of like factors we have written. Same working, make pairs of like factors. Now here we comes that we keep our left hand side as it is, and from right hand side, as all the pairs are complete, from each pair we take out one factor. So here comes 2 into 7 into 7. What comes the answer? 98. So square root of 9604 is 98, which you have obtained by prime factorization method. Isn't it so simple to solve? It's there. Comes the totally different question. Now I am not going to give you a question where you need to calculate the square root by prime factorization method. I am asking you to find out the least number with which you can multiply the given number to make it a perfect square. To make it a perfect square. Say I give you a number 180. You have to find the least number by which you can multiply to make it a perfect square. But the process remains the same. You do the prime factorization of 180. Here is a prime factorization of 180. Can you see? Let's express our number 180 as the product of its prime factors. Expressed. Very nice. Now make pairs of like factors. You have made. Along with me you have made. Now what is left? 5 is the number which is left unpaired. So the number that is left unpaired with the same number, we multiply the given number to make it a perfect square. So what explanation you will give? As 5 is left unpaired, so we multiply 180 by 5 to make it a perfect square. On both the sides we will multiply, and what we are going to obtain. Now if you can see, I have already multiplied on both the sides. Children, whenever you multiply or divide, you have to do the same working on both the sides simultaneously. As here we need to multiply by 5, we will multiply on both the sides by 5. So the number obtained would be 900. Now if in addition it is asked that you find the square root of the number obtained, very easy. You introduce the square root sign on both the sides. Fine. Now make pairs of like factors, and you can see all the pairs are complete. So pull out one factor from each pair. The answer is 30. So, square root of new number obtained is 30.